All right. Going back to radioactivity again, all right. We have radioactivity. It is the breakdown of the atom. Now, more specifically, the pieces that break off and fly out of the atom come from the nucleus. So everything that comes out of an atom comes from the nucleus breaking down. Now, there are 5 different kinds of radiation, but there are 3 main ones, and then there are 2 oddballs. Okay? So when we think about radiation, normally we list the 3 main ones, and then sometimes people add in the oddball ones. And so let's take a look at the experiment. Again, if you take a look at this, you have the box. That's a big lead box. Inside is a piece of radioactive material, and it shoots out one stream. That's just to control us. And it's going to hit a screen again, and we can see it light up where radioactive material actually hits. Now, what's going to happen is we're going to do an experiment by putting a plate right here below and a plate right here above. It's going to be an electrical plate. And an electrical plate, you have one end is negative and one end is positive. Okay? And the stream of radioactivity is going to go between them. And here are the principles. Okay? Like repel, opposites attract. Okay? Like repels and opposites attract. You've heard that before. And so if we take charges and we put that together, a plus and a plus repel, go away from each other. A minus and a minus go away from each other. But a plus and a minus come together. Okay? So that is going to help us interpret what we see. Okay? So let's watch. All right. Nothing is influencing them. They're all going through and they're all hitting one spot. All right. We're going to introduce the magnetic field. What happens to that one stream? It gets broken up, right? Into 3 different pieces. Okay. One piece is called the beta particle. One piece is called the alpha particle, there it is. And the last piece, it's going to take a while for gamma to pop up, but it's going to be gamma. So alpha, beta, gamma, okay? The original radioactive fraternity, okay? If you take a look at the beta, what charge is the beta, okay? Think about it. Which one is it going away from and which one is going towards? It is negative because it's going away from that negative plate and towards the positive plate. Oh, what charge was the alpha? Positive. Because it went down. If it went down, it's going towards the negative, away from the positive. Now, what was the gamma's charge? Neutral, because it wasn't influenced at all. Okay? And so, there's something else that you can tell. Okay? Let's say I'm standing on a sidewalk, and I see a bicycler coming towards me, and I just get a really bad thought in my head, and I just push them as they go past. What might happen to the person on the bike? They may fall. Okay? What if I see a dump truck coming past and I push on the dump truck? Nothing's going to happen. My push is the same, right? But they're influenced differently. So those charged plates are the same. Which one is lighter? Smaller? The beta particles, because it moves so much more. The alpha particles are relatively heavy. And they actually saw that from the experiment. So the beta particle is tiny, negatively charged. The alpha particle actually has a lot of weight and it's positively charged. And the gamma particle was neutral. Okay? A little bit more experimenting, the alpha particle was found to consist of this: a piece of the nucleus that had 2 protons and 2 neutrons. Okay? It was a chunk. It was a pretty sizable chunk. It weighed 4, and it had 2 positives. Okay? It would be the exact same thing as the center of a nucleus of a helium atom. Okay? The beta particle was found to have the same charge and the same weight as an electron. But that's odd because electrons are negative and the nucleus has protons that are positive and neutrons that are neutral. Where does the negative come from? Okay, we're going to see where that comes from. And then the gamma particle, this is actually not a particle at all. It's gamma energy. It is absolute just energy coming off. It is kind of like an X-ray, but it's even more powerful. Okay? And gamma radiation is can actually really harm you quite a bit because of how energetic they are. If you watch Marvel movies, gamma radiation turn you green and when you get angry, you get really strong. That really doesn't happen, but it can affect your biology. Each time an atom releases a piece, it's called a decay, just like as it's breaking down, decaying. And so it can decay off an alpha particle, it can decay off a beta particle, or it can give off energy. Each time, whether it gets smaller or gives off energy, it becomes more stable. Okay? Now, where are these things coming from? The gamma radiation is just energy, and so somewhere in the nucleus there's too much energy, and so energy is given off. Okay? And hopefully, at the end of that, it becomes stable. The alpha particle, a chunk falls off. 2 protons and 2 neutrons fall off. So, if I look at the way I write them, the mass go down by 4, and the number of protons goes down by 2. Now, if you change the number of protons, you start as one element, and you change what the element is. This is the only way we can change what elements are is by radioactivity, and radioactivity is by God's design. We don't control that. We can't control where it goes, we just know it does go there. We can nudge it along, but we can't change where it ends up. Now here's the weird one. The beta decay. Where does the negative thing come from? All right, this is a wonderful slide for a green-red colorblind professor. Okay? All right, the red one is a neutron. Okay, that's neutral, right? And the neutron is going to throw away a tiny little speck of negative charge. And if it throws away a negative piece of it, what's left over? Something that is positive. So, in a beta decay, 1 proton is lost, 1 neutron is gained, and the little negative piece flies away. 1 neutron is lost, 1 proton is gained. Now, as the proton gains, I add 1 proton, I change what the element is. But I don't change weight, because I lose 1 and I gain 1, and that becomes 0. So no weight change. All right? All right. Those are the 3. Alpha, beta, and gamma are the 3 main radioactive particles or energies that come off a nucleus. Here are 2 really strange ones. Okay, something called electron capture. Some nuclei are unstable, and if an electron flies in there and hits a proton, a negative and a positive come together to create a neutral. I change the element because I reduce the number of protons there. That's a very rare, but it does happen. Okay, and it becomes more stable. And then there's one called a positron emitter. Now, positron sounds like an electron, and it has the same shape as an electron, but it's a little tiny positive instead of the little tiny negative. So what happens? The green one is the proton. It throws away its positive to become neutron. Okay? And so the positron is thrown out. That's a really strange one. Although medicine uses that one, and I'll show you that at the end, a positron emitter. Okay? All right. There is a worksheet that is behind the periodic tables. What I'd like for you to do is to work on that first one, the first page, right behind, okay? And it has a radioactive element, and it's throwing off a piece of radiation, and you can see the cartoon sketch, okay? And it asks you to answer questions about that. Now, a lot of people get confused about question number 3, the way it's worded. It says, what is the composition of the radioactivity? What I'm asking there is, okay, it's radioactivity, it's a radioactive piece, what is it made of? That actual piece, what is it made of? That's what is asked of the question number 3. Okay, and so work in pairs and groups and answer all the questions, and then we'll go over it. Okay, give you a little bit of time to apply the knowledge.